Okay, something I'd like to do right here within the gravity unit is what I like to call counting zeros. It's often used whenever you're doing a back of the envelope calculation, just a rough estimate of what you should be getting, give you an idea if your number is right or wrong. So let's just make up some kind of crazy numbers here and see what we can kind of get them and see just if we're going to be close. So let's just multiply a few things together. Let's just take like 8 times 10 to the 13th times, I don't know, 2 times 10 to the negative 4 times 7 times 10 to the 31st. And then let's divide it by, oh, I don't know, 17, or yeah, 1.7 times 10 to the 4th cubed, okay? What does that equal? I don't know, but we can kind of get a good idea of what it should equal by basically counting zeros here. What we're going to do this is we're going to look at the quantities in the numerator first. And specifically what we're going to look at is we're going to look at these times 10 to the values. These are how many zeros are either kicked onto the end or how many kind of decimal places are preceding this. So when I'm looking at this, what I should be doing is I should be taking all the positive values and negative values and adding them together. So I'm going to get 13 minus 4 plus 31, and that gives me an idea of how many zeros are either trailing or leading this number here. So 31 minus 4 gives me 27. 27 plus 13 gives me 40. So there are 40 zeros right now after whatever our number is, okay? But we need to divide that by the number of zeros in the denominator. And if we look at this denominator, what we have is we have times 10 to the 4th, but that value is cubed. Whenever we have a number that is to like a square or a cubed in this exponent kind of way, what we really need to do is multiply them together. So 4 times 3, as we're all familiar with, is 12. And that's the number that we're going to place here. That's our total number of zeros in the denominator, 12. Now, if we think about this, we've got 40 zeros up top and 12 zeros underneath. And if we take a much simpler example here, like 100 divided by 10, well, an easy way to get the answer to this is to just start crossing out zeros. If you have a 0 up top and a 0 on the bottom, and they're on the edge of your number, you can cross them out. So in this case, we just get 10 over 1, which is 10. And that makes sense. 100 divided by 10 is 10. 10 times 10 is 100. So what we can do here, if 40 of these zeros are in the numerator and 12 are in the denominator, 12 of these zeros are going to go away in the numerator because they're going to cancel out. So what we can do here is, with this quantity, we can just take 40 minus 12, these are the numerator values, minus the denominator values, and that gives us our total number of zeros remaining in the numerator. 40 minus 12 is 28, so our number we get here, it should be something times 10 to the 28th, okay, or something close to that. Now we can get a little bit more accurate here than just saying times 10 to the 28 if we go one step further. What we can do is we can look at the numbers that are existing here, and we can see if we get another 0 out of this. Well, if we multiply these numbers together, like 8 times 2. 8 times 2 is 16. And 16 has a value in the tens position, and this is some value right here. I really don't care what that value is. What I care about is that value could be 10. And that means that this gives us another 0. Okay? Now, if I also multiply this by 7, 16 times 7, well, what could that be? 7 times 6 is 42. And then 7 times 1 is 7. So I would have a number like 112 at this point, which is, hey, we have 2 spots for zeros to exist. So this 28 could really become something like a 30. But this 112 is then divided by 1.7, which is almost about 2. I'm not exactly sure what 112 divided by 1.7 is, but my hunch is that when I divide them, I'm going to get something around the like 60, 70 mark, something around there. And that value only has one extra zero. So my kind of guess for my answer here, because I've got one extra zero, is it's going to be some number, maybe 50, maybe like a 5, a 6, a 7. But because I've got this extra zero here, it's going to be some number times 10 to the 28 plus this extra 29th. And that's just a guess. I'm not exactly sure, but I have a good feeling that I'm going to be around there by some amount. So let's actually try to calculate this. I'll take 8 times 10 to the 13th, multiply it by 2 times 10 to the negative 4th, multiply it by 7 times 10 to the 31st, divide that by 1.7 times 10 to the 4th. And something I definitely forgot to do whenever I was looking at that 1.7 is I forgot to cube that value. 1.7 cubed is still going to be in kind of like the ones digit. You know, maybe it's going to be like 8, something around there. You know, a little less than 8. But that's still going to give me something in the tens there. So when I do this, divide by 1.74 times 10 to the 4th to the cube, I end up getting here an answer, final answer of 2.28 times 10 to the 29th. Which, hey, look, there's the 29th. That's what kind of makes sense. So that's what I just calculated there. You kind of know what the answer should, in general, be more or less before you actually start picking up your calculator at all. And all you have to do is really add and subtract zeros together. It gives you a really good idea of what's going on in a problem. Some people don't even like to put the numbers like 8, 2, 7, and 1.7 in. Some people just like to say those numbers are all 1 and just give me the 28 here, and I'll see if I'm pretty close to that within 1 or 2. And that's a fine thing to do. It gives you an idea, just so that you're not a billion off and you're like, oh, did I mess something up in my calculator, or is this just a really weird thing that's going on in space? So that's a helpful little tidbit on how to count zeros, make your life a little bit easier whenever you're looking at these kind of space problems where you're not exactly sure what that number should be, but it really does help. So with that, that's finished.